team.
Hi, I'm Malak Mohammed. I'm the team's leader. I got the first place in CoSpace Rescue Under 19 in 2022 in Egypt, as well as the fourth place in 2022 in Singapore, and the second place in 2024. I also participated in China in 2024, and I got the first place in CoSpace Rescue Under 19 in this year's national competition.
My name is Jana Mohammed. I got first place in CoSpace Rescue Under 19 2022 in Egypt, and fourth place in CoSpace Rescue Under 19 2022 in Singapore. I also got second place in CoSpace Rescue Under 19 2024 in Egypt, and I participated in CoSpace Rescue Under 19 in China. I also got first place in CoSpace Rescue Under 19 2025 in Egypt.
I'm Yara Ayman. I got the first place in FLL Global Games in 2019, and I got the first place in CoSpace Rescue Under 19 2022 in Egypt, and the fourth place in Singapore, and I got the third place in 2023, and the second place in 2024, and the first place in 2025.
Hello, my name is Damiana Hanna. I got fourth place in CoSpace Rescue in year 22 and 23, and second place in CoSpace Rescue Under 19 2024, and participated in CoSpace Rescue Under 19 2024 in China, and I got the first place this year 2025 in Egypt.
Executive summary of challenge.
CoSpace Rescue is a simulation platform that recreates real-life emergency situations, focusing on quick thinking and fast actions. An overview of the challenge. Teams program robot to find, collect, and move objects, simulated victims, to a safe area, the deposit area. Robots must complete these missions within a strict 6-minute time limit, highlighting the urgency of real emergencies. Robots are required to move accurately, avoid walls and traps, and stay within the map limits. The main goal is to rescue the maximum number of victims, objects, within the defined time, showcasing effective programming and strategic planning. Strategies and methods used. Efficient zone navigation. The robot was programmed to navigate between specific zones by passing through designated points. Tight corners avoidance. We developed solutions to stop the robot from getting stuck in tight corners. Navigating to super objects. We designed methods for the robot to find and collect super plus objects efficiently.
Results. Zone navigation from one zone to another facilitated smooth robot movement and aided in better RRGGBV collection. Depositing RRGGBV objects created super plus objects, which significantly enhanced the score, often doubling it. And by implementing the corner avoidance method, the robot was able to reduce wasting valuable time. Conclusion. Using the zone navigation strategy and combining it with the previously mentioned strategies and techniques made it easier to control the robot's path, allowing it to complete its mission smoothly and enhancing its score.
The game. The robot is now moving to Zone 1 to collect black and cyan objects. The robot is now collecting a black object, a cyan object, another cyan object, and a black object. The robot is now moving towards Zone 5. It's collecting a red object. It collected another red object. The robot is now moving towards Zone 9, then Zone 8 of the deposit. The robot is now depositing and creating a super plus object. The robot is now moving towards Zone 11 to start the cycle from the beginning to form a new super plus object. The robot is now going to collect the super plus object. It's collecting the first one. And now it's moving towards Zone 5 for the second super plus object. It collected a cyan object, a red object, and another cyan object. The robot is collecting the second super plus object. And it's now moving towards Zone 1 to collect the last super plus object. The robot is collecting the super plus object. Strategies and innovative solutions.
Fixing bugs. The robot often got stuck between the wall and traps, leading to delays. And to address this, we added a conditional statement to detect these areas. And when the robot reaches these zones, it adjusts its path to avoid getting stuck.
How to navigate through zones.
Path planning. The robot's movement path is manually defined in the program. Each zone is assigned a specific set of instructions, including directions, speed, checkpoints, and actions to perform. Zone transitioning. Transitions between zones are controlled based on two main factors. The first factor is loaded objects. The robot checks if an object is loaded through sensor or input condition. The second factor is time spent in a zone. The robot remains in a zone for a programmed duration before proceeding. Sensors. The robot uses two essential sensors to support navigation. Ultrasonic sensor, which detects obstacles to avoid them, and color sensor, which detects traps to also avoid them.
Applying knowledge gained to the real world. After industrial accidents or natural disasters, the collection of information becomes crucial, and robots can be precious allies to assist with this. These ground robots and drones were developed within a European research project. Remotely controlled, their mission is to research and explore the accident site. They can even create digital maps of the environment in 3 dimensions. There is a laser sensor on the robots that measures the distance on a map in 2 dimensions. By rotating, it makes it possible to create a truly 3 dimensional map. Most of the time, they use 2 or 3 robots, each of which is equipped with one of these sensors. The aim is to merge all the measurements together to have a global representation of the environment. The goal is to better assess the risks and protect the lives of the rescuers. Experts in robotics work directly with the final users, which are the firefighters. Robots can carry any sensor needed in a particular situation, such as exposure to gas or radioactivity. Some even have articulated arms to gather samples for researchers. Scientists were able to put their research to work during the devastating earthquake in 𝑹𝑪𝑨𝑷, central Italy, last August. At the request of the firemen and the authorities, they managed to deploy their robots to assess the damage of two classified 14th century churches. It was a difficult mission because the churches were in a very bad condition, so much so that the firefighters couldn't get in to make a detailed analysis. First, a robot came in to monitor the back of the church, and then another robot entered at the front. They then managed to get a drone inside and filmed the entire interior, which resulted in a 3D model. AI tools used.
We use Clipchamp to edit our video presentations, as well as Gemini to overcome some bugs during coding. Effective time management is key to maximizing your team's potential in a competition. Breaking down tasks based on each member's strengths ensures that everyone can contribute effectively. Looking for innovative ideas online can spark creativity and help you find unique approaches to problems. Engaging with videos and presentations from experienced developers not only offers practical techniques, but also helps you understand different perspectives that can enhance your coding solutions.
The end.